This is lesson 47, pages 100 and 101, and it is segment measures. Now, this lesson is very similar to lesson 42, where we talked about the measurements of tangents to a circle. I went on and drew the pictures, so you may want to stop at each point and draw the picture. I do not have Post-its for these and will not have them. So you'll need these pictures. I just used a bottle cap to draw the circles and then just some kind of straight edge to draw the segments. The first one is when you have two chords. And if you remember, chords are segments that go across a circle. They can be a diameter. They don't have to be a diameter. And in this case, we're going to be talking about the relationship between each of the parts of the circle, each of the parts of the chord. So I'm going to set up the proportion, and then I'm going to label the numbers, and then we'll do the arithmetic. So in this case, if you'll look at this chord here from A to B, then we're going to take the little piece AE. Notice it doesn't have a bar of it, so we're going to talk about its measure, times the measurement of EB, the other part of it, and that's going to be proportional with the parts of this chord. So it would be segment CE times segment ED. So we're going to label them. We're going to let this be 7 and this piece here be 16. And then we're going to let CE be 14. And we're going to let this piece be our X, the part we don't know. And so we just set up a proportion. So the two pieces of AB, which would be 7 times 16, equals the two pieces of CD, which is 14 times X. 7 times 16 is 112, equals 14X, divide by 14, and X is equal to 8. So anytime you have the two chords inside, you just set up the proportions and multiply. Now, the two secants are like extended chords. It's when your chords continue out and then they intersect out here at a point. So in this case, we've got the relationship, and I actually am going to write it out and then we'll do a problem because this one's a little messier. We're going to actually take, and I'm going to write the statement. It's going to be the whole secant times the exterior part equals the whole secant. Let me see if I can adjust that light. It just seems like it's glaring a little bit. Times the exterior part. Now, once you see, it's not that difficult. So let's start with the top one. So the whole secant would be from H to F. And the outside part is this GF right here. And then take the whole secant from J to F and multiply it by just the outside part. And that's the proportion. Now let's label some numbers. We're going to let this piece be a 7, this piece be 11, this one be 6, and this one be X. So as we do the whole secant, we're going to do the top one first. So the whole secant would be 7 plus 11, which will be 18, times just the part that's outside, which would be the 7. And then the whole secant is 6 plus X. Notice I scooted it over a little bit because you're going to multiply by the outside part, which is the 6. See, 6 plus X would be the whole thing. You know, if this was 10, it would be 16. So this is what we don't know. We add them together, and then the outside piece is 6. Most people like to distribute from the front. You could have put it at the front or back. So 126 equals, and then we're going to distribute that 6 and get 36 plus 6x. Subtract 36. Let's see if I can straighten that up. We get 90 is equal to 6x. And I get that divide by 6. And I get x is equal to 15. third one is a tangent and a secant. And again, if you want to stop, get the pictures drawn, and then fill in after you go back and do that. So I've got, let's see, what do we have here? OM, MK. Okay, it's going to be the whole secant. Now this is the secant, this is the tangent. So we're going to use the whole secant times the outside part, just like we did on the other one, exterior part, is equal to, now because you only have one thing here with the tangent, we're going to take the whole tangent and multiply it by itself. Now you can write squared, and that's probably what we'll do when we do the problem. You're going to actually just multiply that one twice. So let's take our picture. Now notice in this case our tangent is up here. Remember, a tangent just touches the circle in one point, and that's going to be 6. Our inside piece is x, and our outside piece is 4. So I'm going to do the secant first because that's what I have set up here. So the whole secant, oh, I didn't come back and put the letters. Let's do that. The whole secant was OK, and the outside part was MK. The whole secant was LK, and you can write it, that's an L, not an angle, LK, or you can write it LK squared. I'll put or like that, because I think that's the notation I'm going to use. So in this case, let's do the secant first. So the whole secant would be 4 plus x. So I'm going to write x plus 4, 4 plus x, and we're going to multiply it by the outside part, which is the 4. And I like to put that out front. Multiplication is commutative. And then we're going to take the tangent, which is 6. You can put 6 times 6, or you can put 6 squared. Same thing. So we'll distribute on this side. 4x plus 16 equals 36. Subtract 16. And we get 4x equals 20. Divide by 4, and we get x equals